Hey everybody, what you're going to see in this video is a clip from a bigger video on factoring complex trinomials. It's walking through a method called fast factoring in dealing with a trinomial that takes that form where our leading coefficient is not equal to 1. So this is going to cover the theory behind what we do or what we can do within fast factoring. Okay, I hope it helps you. So what you see sitting in front of you is, I would argue, our first complex trinomial that we're going to factor. You can notice pretty quickly that there are not any common factors in all three terms. So we don't have the option that we just had in question B. What I want to do now is I want to take you through the theory that I use to be able to fast factor. So we're going to mark up the page quite a bit. We're going to tackle the problem multiple times. And finally, I'm going to show you the way that I walk through it, the way that I would factor this expression. So what I want you to do is hang tight. Don't worry about copying anything down if you're working along with this. Just kind of sit back and let's walk through some of the theory that we use to be able to fast factor, that is, factor in one line. Okay, first off, we notice that if we have a trinomial that takes this sort of pattern, a single something in the middle term and a squared something in the first term with a constant on the end, that it will factor into a binomial times a binomial. Okay, we've patterned that out through expanding binomials. So we know that if we finish with a squared something, single something, constant, then it must have come from a binomial times a binomial. Okay, with that in mind then, really for us to factor this, we just need to figure out what are the four missing parts within the binomials. So you take a peek at it. I need to come up with the four missing things. Now, what are the things? Well, first off, I am really hoping that we can tell that x is our variable. I think we're in deep trouble if we can't tell that x is the variable. So that's a given. We almost don't even worry about it. Then what we need are the two coefficients and the two constants. So what I want to focus in on right now are the two coefficients. So let's focus in on the red. I would hope that we've got enough experience that we know if we were to expand those brackets, this first term times that first term is going to be what gives us our x squared term. And specifically, the two coefficients, when multiplied, give me my 2. So what I'm looking for then are two numbers that multiply to give 2. Well, that's pretty easy. 2 is a prime number. So I know it's got to be a 2 and a 1. So I'm just going to jot those numbers off on the side. Okay. I could even put those in my brackets. Remember, this is not how I actually factor it. It's just the theory behind it. But I could put that in my brackets. So what I'm going to do is I'm going to get rid of these circles that were missing, that represented the missing number. And I'm going to get rid of all of that red arrow because we should be good that there's got to be a 2 and a 1. Now I know you don't write the 1 in front of the x, and I would never want that 1 in front of the x. But for now, I'm going to write it in just so we can visualize it. Okay. Let's skip over the middle term, because I know that my middle term is made up of two other terms. And so what I want to focus in on now is the constant at the end. You'll notice we are missing the constant from the first bracket and the constant from the second bracket. Now, we should have enough experience that we know when we fully expand those brackets and you take this constant times this constant, then we have to get that constant. So we're looking for two numbers that would multiply to give 3. And just like before, hey, it's a prime number, so that's pretty easy. It's 3 and 1. Now, the only part for us is we're not quite sure where to put the 3 and the 1, and we're kind of fixed because we put in the 2 and the 1. So I'm going to erase all that purple again, and I'm going to end up getting rid of my purple circles. This now becomes our options. I know that the two numbers I have to be 3 and 1. I'm just not sure where to put them. That is, should it be a 3 and a 1? Or should it be a 1 and a 3? And so what I do then is a little bit of a check. And this is where kind of the guess and check comes in. It's a check. I'm not sure where it goes, so I'm going to confirm it by doing a little expanding. Now, people who don't like this method, they hold on to that guess and check a little bit too much. No, it's not really a guess and check. It's just that I don't know for certainty until I check. So what I'm going to do then is I'm going to go back to my original. I originally had written down a 3 and a 1. And so what I'm going to do then is I am going to expand, and I'm going to do it in my head. So what I'm going to do then is I'm going to say, if I were to expand those brackets, I would eventually get a 2x and a 3x. And you can see that if I were to multiply those terms together, there's my 2x and my 3x, and putting those together give me options. If I have a 2x and a 3x with no signs on them, then if they were both positive, I could end up getting a 5x. If they were both negative, I could get a negative 5x. If one of them was positive and one of them were negative, then I could get a 1x or maybe a negative 1x. So I have all of these options when I go through. The most important thing while I'm checking that is that they don't give me a 7x. And that's what the middle term was that I was looking for. So I know for certainty that I can't put the 3 and the 1 in those positions. So what do? I switch them. I swap them out. I'm going to then try the 1 there and the 3 there. And then I do the same thing again. I just check. So when I expand that, I see I'm going to get a 6x. And when I expand that, I see I'm going to get a 1x. And even faster now, you can see, hey, a 6x and a 1x, those can come together to give me a 7x. I just need both of those to be positives, because a positive 6x and a positive 1x gives me a positive 7x. So how can I ensure that those are positive? Well, let me first get rid of all of those green arrows. And now that I've figured out that the 3 and the 1 are in the correct spots, all I need to do is put their signs on. So what I end up getting is a positive 1 and a positive 3. And you can now see, if I get rid of all that green underline, we have come in with our brackets. That 2x squared plus 7x plus 3 equals 2x plus 1 times 1x plus 3. Okay, there was the theory in what I was doing. Now what I want to do is I want to kind of show you a mixture. I'm going to show you the way I factor and the way it creates my brackets. Okay, so what I'm going to do then is I'm going to get rid of what you see on the screen. Just remember the little 2 and the 1 over on the right side. Okay, so if I now get rid of what you see on the screen, we're going to start off by using a little guess and check chart. Okay, I'm going to now factor this expression. And because of the pattern with the squared something, single something constant, I know that if it factors, I'm going to get 2 brackets. Now, the obvious part of this is I can see that I'm going to have x's. So I'm not going to write those in right now. I'm going to wait. Instead, I'm going to focus in on the 2. That's my leading coefficient. That's the coefficient of my squared term. And I know that I can find that by multiplying my 2 x terms inside my brackets. So I'm asking myself 2 numbers that multiply to give 2. And I know that that's a 2 and 1, and you'll see me jot down the 2 and 1 again. What I'm going to do off to the right is I'm going to create my guess and check chart, or what I call it now, my fast factoring chart. Okay, I'm going to jump over the middle term because it's made up of multiple terms, and now I'm going to focus in on the constant at the end. There's my 3. And I ask myself, hey, 2 numbers are multiplied to give 3. 3 and 1. And I write those down at the end as well. What the red 2 and 1 and the green 3 and 1 are representing are my brackets. I'm creating my factors within my fast factoring chart. I'm just not writing all the stuff that I already know, the brackets and the variables. Okay, in my fast factoring chart, if I were to take that right now and move that into the brackets you see in the orange, this would be one of my brackets. So I would have a 2 and a 3. And this would be my other bracket. So I would have a 1 and a 1. Remember, we know where the variable's going. So what I'm going to do then is I'm going to now check and see, does that get me to my middle term of 7x? So I would take that 2 and I would multiply it by the 1, and I would take that 3 and multiply it by the 1. Can I get you to look over at my fast factoring chart now? I'm going to take my 2 and I'm going to multiply it by my 1, and I'm going to take my 3 and multiply it by my 1. Notice that when I expand binomials, I always take a value in the first bracket and I multiply it across to the other bracket. I never multiply it by what's in the same bracket. So you can see in my fast factoring chart, I do the same. Some people just kind of remember it as, well, you cross multiply. But really what I'm doing is I'm multiplying it into the other bracket. Now, when I do that multiplication, what I end up getting is a 2 times a 1, which was a 2, a 1 times a 3, which is a 3, and I see that there's no way that I can put those together to give me a 7. So I put my items in, my terms, my coefficients. I put my things in the wrong brackets, just like we did before. So what do I need to do? Well, I'm going to get rid of my failed attempt. I'm going to get rid of my blue arrows. And now what I'm going to do is I'm going to get rid of my 3 and my 1. So over in my fast factoring chart, I'm getting rid of my 3 and my 1. And what I need to do is I need to flip it. This was the act of me switching the 1 and the 3 from my brackets. So if I were to write my fast factoring chart that way, now the 1 and the 3 have switched their positions in the binomials. And now I go through the same process again. If I were to expand, you'd see the blue arrows. You can see those in my fast factoring chart. And when I do expand those, then I get a 6 and a 1, and I can get 7 out of that. I need it to be a positive 7, so if you look back at your binomials, I can now put in my signs. Both of those have to be positive. And now I'm going to put back in what the easiest thing was, which was the variable. And you'll notice we have factored our complex trinomial. Okay. Now, that still isn't the way that I actually go through and I factor a complex trinomial. What I want to do now is I want to show you the exact same way I would factor this. The only thing that's going to happen is it's going to be a little slower because I'm talking to you about it. Okay. First thing I do, I'll write down my equal sign. Maybe. Actually, I'm going to do it the exact same way. No, I wouldn't. What I'm going to do is I'm going to look at that, and the first thing I look for is a common factor. And I notice that there's nothing in common in all three terms, so I have a complex trinomial, so I'm going to jump over to my fast factoring chart. I need two numbers that multiply to give 2. That's 2 and 1. So I'm going to write them above just as you see. Now I'm going to jump over to the 3 at the end. And I'm going to ask myself, hey, two numbers that multiply to give 3, and that's 3 and 1. I don't give a whole lot of thought right now. We're just getting used to it. We will spend some time thinking about the order that we write those down in first when we get a little bit better at it. But for now, I'm just going to jot down 3 and 1. And now what I'm going to do is I'm going to practice multiplying across to the other bracket. So when I multiply across, I get a 2 and a 1, there's a 2. I get a 1 and a 3, that's a 3. So in my head, I'm keeping the numbers 2 and 3. And I'm asking myself, is there any way that I can put those together through adding or subtracting that will get me my middle term of 7? Nope. So that option didn't work. So what I do is then I flip my 3 and my 1. This is the act of me swapping them in their brackets. Now I look, I multiply across, I see that I get a 2 times 3, which is a 6. I see that I get a 1 times 1, which is a 1. Can I get a 7 out of a 6 and a 1? Yes. If both of those are positive. So what I do then is I write in the sign that I'm going to put in between my terms. Now, the other reason why I write in that sign is so that I can get a little extra check. Notice the signs on my green terms are both positive. And when I multiply a positive times a positive, I need to get a positive term. And so I get some confirmation that what I have in my fast factoring chart is correct. Those represent the factors of that expression. So all I need to do then is write out my fast factoring chart and put in the stuff that was obvious at the beginning. Brackets, variables. So I'm going to take my fast factoring chart and I'm going to start to write it out. I know it's going to equal, put in my bracket, a 2, put in my variable x. I see the sign in between plus. I see my 1, close my bracket. Notice, what I just wrote down was what I saw on top of my fast factoring chart without the variables in the brackets written. Now, drop below, and I'm going to do the same thing for my second bracket. There's my bracket. I have my 1, put in my variable, my x, put in the sign between. I have my 3, put in my variable, and I'm good. The only thing I wouldn't do is I'm not going to write a coefficient of 1 out in front of that variable because that's bad form. And you can now see how I would factor that complex trinomial. So using a fast factoring chart can be really, really helpful. It can just allow you to jot a couple numbers down so that you can work your way through and you can see some stuff. That way, if you don't find a combination that works right at the very beginning, like we didn't here, You have the ability to try another option, see the options you've tried. You're not trying to keep all these numbers in your head. I think your fast factoring chart could be your best friend as you're working through and factoring complex trinomials. I would like to get rid of that orange off on the side because those are numbers I never write down. I just keep them in my head. You may like to write them down as you factor. Okay, what I want to spend the rest of our time together doing is continuing to practice using our fast factoring chart, but I also want to spend some time talking to you about some of the things you can see in your complex trinomials that allow you to rule out certain guess and check options at the very beginning. Ultimately, what that does then is it makes you even faster at fast factoring. So let's get some practice, let's work our way through, but let's also start to kind of pick up some of these ways that we can become even better at factoring.